Okay, good morning, everyone. Hope you had a good weekend. We are going to be continuing what we had started last week with percents and applications of percents today. Before I start, are there any questions that you'd like for me to address at this moment? Everyone's okay? Okay, well, in that case, we're going to pick up with applications of percents. Now, I was looking at our calendar, and we are very, very far behind, which I kind of anticipated would happen. Today, we're actually supposed to be starting, today's the 22nd, we are supposed to be starting linear graphs, slope-intercept method. Okay, that's what we're supposed to be doing today. We should have already covered the intercept method on linear graphs. So we still have to finish applications of percents, talk about mixtures, and then get through all this conversions. So what I've decided to do is I'm going to jump past the scientific notation in the imperial systems of conversions. Those are actually really important sections, especially for anyone going into like nursing or anything like that. And I thought, since this is kind of its own thing, we would be fine just to kind of stick it in at the end. And what I think I'm going to do is I'm going to trim out something, either the systems of linear equations, matrices, I might trim that out, or I might not do as much with the exponential and log functions and just stop at rational functions. I'm not sure, but there's stuff here that we can kind of, I guess, not completely get rid of, but at least reduce it a little bit so that we can get this conversion stuff in order later on in the semester. So I'm not going to change the calendar. We're just going to kind of try and get caught up, and we'll do that today. We're going to see how far we can get. Okay, so everyone okay with that? I guess you don't have a choice, but I hope you're okay with that. So let's get to today's stuff. We are going to continue this applications of percents, and there was a formula here that we had not talked about. It's this one right here. And this formula is a formula that we use to figure out how much something increases or decreases in terms of a percent. So a classic example of this, I guess I could give you, would be something like, you know, let's say you're paying rent for an apartment, right? Let's say your monthly rent is, I don't know, let's say $500 a month, right? And then your lease comes up after 6 months or whatever, and they say, hey, okay, well, you want to sign a new lease? You're like, yeah, I want to stay here. I love this place, whatever. They say, okay, your rent, the new rent is now going to be $600 a month. So we know that it went up by $100 a month, but what is the percent increase? By what percentage did that number increase? And so we just use this formula. The formula is you take the new cost, you subtract the old cost, and you divide by the old. So the new cost for us in this problem would be 600, right? That's the new rent, minus the old cost, which is 500, and then we divide that by the old cost, which is 500. So we go ahead and we do everything that's in the numerator first, okay? So we have to do the 600 minus 500 first. We get 100. We divide that by 500. And if you do that on a calculator, you're going to get 0.20. 0.20. Now that is the correct answer, but we have to convert this answer to a percentage. So remember, when we convert to a percent, we always take the decimal place and we move it 2 places to the right. So we move it 1, 2, and that will give us our answer of 20%. So rent went up by 20%. So it was a 20% increase. Does this make sense? It's pretty straightforward. As long as you get things in the right place, then you're good to go. Let's do another example. So remember I shared with you all that I get on these little workout kicks, and like every year or so, and I try and lose weight and get healthy and all that. Okay, so I lost a significant amount of weight, and I'd like to know, what was the percent decrease that I had in my weight. Okay, so when I started back in June, I'd gotten myself all the way up to almost, well, I mean, I think there was a day where I was 200 pounds. Okay, and as of today, okay, so today, I think I weighed in at like 140, no, 174.3, I think is what I weighed in today, pounds. Okay, so I would like to know how much I lost as a percentage. So let me call on somebody here. It's been a while since I've called on Sebastian. Is Sebastian around?
Yes, I'm here.
Okay, hey Sebastian. So I would like to know by what percent my weight decreased. So if we're going to use this formula, new minus old, my handwriting is terrible today. I don't know why, I feel kind of shaky. You ever had those days where you just feel kind of shaky? I don't know what's going on.
A little bit.
Okay, Sebastian, so what is our new number? What's the number I'm going to use for the new?
174.3.
Yep, that's my new, and that's my old, right?
Yep.
Okay, so do you have a calculator handy?
Yes, sir.
Okay, why don't you go ahead and see if you can't crank this out. And I think 200 on the bottom also, right?
Yep.
Okay, so when you do 174.3 minus 200, you're going to get a negative number, aren't you? What is it, like negative 25.7 or something like that?
Yeah, negative 25.7.
Go ahead and divide that by 200 and tell me what decimal you get.
Negative 0.1285.
Negative 0.1285. Let's convert that to a percentage. So just two places to the right on that?
Yep. So
12.85%. Now, what we have to realize here, good job, Sebastian, we're done. What we have to realize here is that this is not an increase in weight, right? This is a decrease in weight. So when I write my answer, I'm going to have to put in here that it's a 12.85% decrease. And the thing that'll tip you off as to the fact that it's a decrease is the fact that we had a negative. The negative is telling us that we went down instead of up. And in the previous problem, we had a positive answer, right? So that means it was an increase. So I lost almost 13% of my weight, of my body weight in the last few months. Make sense? I think this formula students usually have no big issues with this. Just be careful that you don't get the new and the old mixed up. Okay, that's it for that. I don't think we need to go really through any more examples. Let's talk about mixtures. This will be our last topic before we get into mixtures. Did I pass it up? There it is, mixtures. Okay. So these problems these can be very difficult problems depending on what information you're given. But in this class, we keep it pretty straightforward. So the idea is this. Let's say that we have some container, okay, that has, let's say, fat-free milk. And let's say in this container, we have 3 cups. Okay, 3 cups of fat-free milk. So fat-free milk means that there's no fat in the milk, right? There's none, 0% fat in here. Okay, so 0% fat. Now that is not given to us. We have to understand that when it says fat-free, we have to deduce from that that there's 0 fat in there. Okay, well, I don't like fat-free milk. To me, it tastes too much like water. But whole milk is like too rich for me, right? So what I'm going to do is I'm going to mix these two together to make a milk that's a little less, has a little bit of fat, but not as much as whole milk. Do we know how much fat's in whole milk? I have no idea. Let's look it up real quick. Where's my? Fat percent in whole milk. We'll just go with this number, 3.25%. Okay, so I'm going to take this and I'm going to add to this another container. And let's say that this container only has 1 cup of whole milk, which means that it has 3.25%. Okay, y'all okay with this so far? We're going to pour both of these together. Okay, we're going to get a new container. We're going to mix them into a container. And my question, I have 2 questions about this new container. First of all, how much milk is in there? That's the easier question. How much milk do we have? The second question is, what is the fat percentage? All right. So if I take 3 cups of fat-free milk and mix it with 1 cup of 3.25% fat milk, at the end of that, how much milk do I have and what is the fat content of that new milk that's mixed up? Is that clear with everyone as far as the question? Okay, so who wants to answer the first question? How much milk is there? That one's the easy one.
4 cups.
4 cups, right? We had 3 cups, 1 cup. We mixed them together. We now have 4 cups. So that part, all we do is add the 3 plus 1. Let me make this a little bigger. So how much milk? We have 4 cups. All we did was we took 3 plus 1, right? No big deal. Here's the harder part. Okay, here's the harder part. When you think about milk, right? There's fat in the milk. Well, unless it's fat-free. If I tell you that there's fat in the milk, there's fat like mixed into the milk, right? It's mixed in, like you can't sit there and see it. But let's imagine that we can, all right? Let's imagine that we could see the fat. In this first cup, how much fat would be there? Well, it's fat-free, right? So there's none. There's no fat there, right? There's 0 fat. Now, when I say 0 fat, I'm not even talking about a percent. I'm talking about like how many cups of fat. Okay, so I'm gonna actually write that down. How many cups of fat are in those 3 cups? Well, the answer is 0 because it's 0%, right? But let's ask the same question for this one. How many cups of fat? Do you all agree that there is some here? There is some, right? But it's not the whole thing. Like the whole cup is not just full of fat, right? There's other stuff in there, water and whatever else is in milk. So if we could see it, right? If we could see the fat, maybe we'd separate it and it would be here on the bottom, and that would be our fat here on the bottom, right? How much is there, right? That's my question. How many cups of that 1 cup, how many cups is fat? So would you say that half a cup is fat? Or more or less? What do y'all think? What's the percentage of fat in that cup or in that container?
3.25.
3.25. Okay, so to have half of it be fat, we would need 50%. It would need to be 50% milk, right? 50% fat to be half. So we have a very little amount. To figure out exactly how much we have, what we need to do is we need to take the fat percentage, convert it to a decimal, 0.0325, take that number and multiply it times the amount that we actually have in here, which is 1. So if we multiply that, what do we get? How much fat? So we just multiply those two together. You have 0.0325 cups of fat. Now, we said on the first one, didn't we say there was 0 cups of fat? We could have got the same answer doing the same exact operation. Take the percent fat, which is 0%. 0% as a decimal, still 0. Multiply it times the 3 cups, and we'd still get 0, right? 0 times anything is still 0. So what we're looking at is this. From the first cup, we have no fat. From the second cup, we have 0.0325 cups of fat. So how much fat is in the new mixture total? How would we figure that out? Take those two and just add them together, right? That's how much fat's in the new one. So if we add these, we just get, I'll add them over here, 0 plus 0.0325, and that's just 0.0325 cups of fat. Okay, I'm going to do another example after this. If this one's not making a lot of sense, just let me do 2 examples, and then I think after 2 you'll catch on a little better. Okay, we've not answered the question. What is the fat percentage in the mixture? So to find the fat percentage, we need to figure out how much fat over the total amount, right? That's what a percentage is. It's the part out of the whole. That's what we learn when we learn percentages. What part out of the whole? So how much fat do we have in this new mixture? We just calculated that to be 0.0325. Now, here's the thing. How much do we have in the mixture? How much total is in the mixture? How many cups? We answered that in the first question, didn't we? We now have 4. Right? 4. So we divide that by 4, and this will give us our new percentage. So we get our calculators out, and we do 0.0325 divided by 4, and I get 0.008125. And if I convert that to a percentage, move the decimal place 2 places to the right, then I'm going to get about 0.8125%. 0.8125% is a little less than 1%, right? Because that's 0.8%, it's not even 1%. So what I've essentially done is I've taken fat-free milk and I've taken whole milk, I've mixed them together, and I've basically made almost like a 1% milk, which you can buy 1% milk, I think. You can buy 1% milk and 2% milk. Okay, again, if you're confused, let's just do another one, okay? And let's see if you can catch on to this. The main idea here is this part that's happening down here. This right here is the main part of this problem, is how you figure out how much fat is in each one. So I'm going to do a problem very similar. We'll stick with milk again. What if I take, let's use different measurement. Let's go 20 ounces of 2% milk, and I add to that 30 ounces of whole milk. Okay, question. How much milk do we have? Second question, what is the fat percent? Okay, so the first question is the easy one, right? You just see how much milk do you have in the first one? 20 ounces. How much is in the second one? 30 ounces. You add those together, you have 50 ounces. So I have 50 ounces of milk. Now, here's where we have to go figure out how much fat was in each of these containers. So to figure out the first one, does someone want to tell me what I'm going to do? What I'm going to multiply together to figure out how much fat was in that first one?
.02 times 2.
0.02 times, close, not 2. How much milk did we have in there?
2%.
Well, that's, yes, the 2% is what you just gave me, the 0.02. That's the 2%.
Mm-hmm.
And you're multiplying that times how much milk you have there. How much milk do we have?
Oh, yeah. 20 ounces.
20 ounces. Okay, good. So this is your fat as a decimal times your ounces, the amount that you have. If you multiply those two together, that'll give you how much fat you had there. So 0.02 times 20 gives you what? 0.04? All right. My brain doesn't want to work today. 0.4, that's right, 0.4. Okay, 0.4 ounces of fat. Good, good job, Abby. Okay, somebody else, tell me now, following that, how much fat, how many ounces of fat we have in this one. So what two things are we going to multiply here? Anyone want to volunteer, or should I just call someone?
0.325 times 30.
Good. So you're using the point. What is it? 0.325. So Alexis is remembering that when we talked about whole milk, we already said that's 3.25%, right? So Alexis converted that over to a decimal, and then what are you going to multiply that by, Alexis?
30.
30. Okay. So we do that on our calculator. 0.0325 times 30. And we get 0.975. So we get 0.975 ounces of fat. There, right? Okay. Now, what we need to do, we know that's how much fat's going to come from each one, right? So let's add those two together. So we just add those. If we add those together, we get a total of 1.375 ounces of fat. So, I mean, what we need to understand is that when we're mixing these two, obviously we get 50 ounces. Like that's how much milk we're going to have at the end. But of the 50 ounces, 1.375 ounces of that is actual fat. So let's take another volunteer to help us get the final answer. How are we going to get that? What is the fat percent? What do we do with all this information? Who wants it? Who wants it?
Are you going to do the 1.375 over 50?
Yep. Okay, good. So 1.375 over the 50. So it's very important that we're using the total ounces in our mixture. And then we get that as a decimal. 0.0275. And then we convert that to a percentage, 2.75%. There we go. So if you take 20 ounces of 2% milk and 30 ounces of whole milk, mix them together, you now have a 2.75% fat content milk. Okay, it's your turn to do one, but I'm going to change the game on you here a little bit. I'm not going to use milk anymore. I'm going to use something else. So I don't know if any of you do y'all want to leave that up? Can I move, get rid of it? Get rid of it. Okay, so I don't know how many of you have taken a chemistry class, maybe in high school or something. But when you're in a chemistry class, a lot of times you have to use some sort of acid mixture to do chemical reactions. And the experiment might call for like a certain percentage of acid in the, you know, for you to get like a 15% acid mixture, or maybe they need a 30% acid mixture. And usually what happens is your instructor will go to in the lab, there's usually a room where they store all the chemicals, and they'll go back there and they'll like mix some stuff up, and then they'll come back out and they'll be like, here's your acid mixtures. They probably do that before you even get to class. But the thing is, in the back of the lab, they only have certain acid percentages. So maybe in the back of the lab, they have a big container that has like 10% acid in here. And then they have another vat over here that has maybe like 60%. And what they do is they say, okay, I need for the experiment, I need to have maybe a 20% acid mixture. So they have to figure out how much of each of these to mix together to get a 20%. Does that make sense? Just using the 10 and the 60, they somehow mix them perfectly to get the 20. So I'm not going to ask you to do that question. That question would be very difficult. Well, not more difficult than we can handle right now. All right. What I'm going to ask you is the same basic question I just asked you, but I'm just going to use acid instead of fat content. So it's the same principle. It's just acid versus fat. So what if we start out, and let's go with, we'll go with ounces again. What if we take 50 ounces of a 10% acid mixture, and we add to that 8 ounces of a 60% acid mixture? The question is, how much acid do you have? And then the second question is, what is the acid content as a percent? Okay, let's take maybe 5 minutes. I think 5 minutes is plenty of time. Each of you work this out, and then I'm going to call on some people to give me their answer. All right? I will not play Jeopardy music in the background. I'll just let you be, okay? So I just put a poll up on the Zoom. When you're done, just click yes, just so I can see if people need more time. Okay, I think that's probably good. Let's see here. Call on somebody. How about Beth? Is Beth around? No Beth? Okay. How about Leah? Leah? No? Right, how about trying to find someone who hasn't replied today? How about Abigail? Is Abigail here? So we're going Abigail Del Rosa.
Yeah, I'm here.
Okay. Did you get something?
Yeah, so like for the first question,
Uh-huh.
I got 58 ounces.
Okay, I think everyone would agree with that.
And then do I give you the answer to the second question, or do I tell you like how I did it?
Yeah, tell me what you got, and then we'll do a quick poll to see if, you know, how many people agree. So
Okay.
go ahead.
I got 16.89%.
16.89%. All right, let's do a quick poll. Just yes or no if you got that answer. If you're off a little bit with the rounding, that's okay. Wow, okay, good. We have quite a few. It looks like a very strong percent here agrees. Okay, that's enough. I'll just share what I've got there. So, you know, 94% of your classmates agree with that answer. Just tell me the numbers. You took this, we're not even gonna talk about the 58 ounces. Everyone got 58, I'm sure. Here you did 0.10 times 50, right? So you took the percentage and converted it to a decimal, multiplied it times the ounces. And then over here, you converted the percentage, 0.60 to a decimal and multiplied it by 8. When you did that and added those up together, what did you get when you added those together?
I got 9.8%.
9.8 or 9.8, and then that's what you divided by the 58?
Well,
Yeah.
I divided I don't know if I did it wrong. I divided 58 divided by 9.8.
Oh, okay.
But I don't know if I wrote it like that and I put it like the other way in the calculator.
Yeah, let me see. I'm pretty sure you did it right. You multiply those together, you get 5. Here you get 4.8. Add those together, you get 9.8. And then you take 9.8 and divide that by 58. And yeah, so you may have written it down wrong, but you typed it into your calculator correctly.
Okay.
You get 0.1689, and then you convert that to a percentage. So does anybody have any questions on that? We're okay? Okay, good. All right, that is all in terms of these mixture problems. Let me just look at one of these, and just so you can see, I mean, in the problems in the packet, they're not a picture of cups, you know, it's words. So let's just set one of these up. Let's look at number 20. 2 cups of water from the Great Salt Lake with 10% salinity are mixed with 2 cups of swimming pool water with 0% salinity, right? So you've got 2 cups of 10% salt, and you're mixing that with 2 cups of 0%. Does that make sense for number 20? It's the same problem, just in words. Same type of problem. Okay, I'll let you go after that yourself. You should now be okay on your homework assignment for this section. Hopefully you'll have some questions for me, because there's a lot of word problems in this section on percents and proportions and mixtures and things like that. So that means on the test, there's going to be quite a few word problems. So make sure you're comfortable with these, and that way you don't get surprised on the test and be like, oh my gosh, I don't know how to do word problems. So maybe next class you'll have some questions for me. Okay, we are going to move on. We're skipping scientific notation. So that's going to put us all the way down to, here we go. We're going to be on page 49 now. And we're going to be talking about linear graphs. So page 49 is where we're going to be, linear graphs. Okay, so let's start this out with just a brief conversation about equations and things that we've done already. So, for example, if I put this equation down here, 2x plus 4 equals 8, and I ask you to solve this, then you'd look at that, hopefully you'd recognize that it's an equation, right? And that you have the variable here, x, that you're trying to solve for. So you would go through and follow the procedure that we established, a couple of weeks ago, which is, clear fractions and decimals, clear parentheses, collect like terms, isolate the variable, make sure that the coefficient on the variable is 1, right? All that should ring a bell somewhere, right? So you would go through here and subtract 4 on both sides. You'd have 2x here, over here you'd have 4, and then you divide both sides by 2 to get a coefficient of 1. So you get x is equal to 2. So what we've done is we have solved the equation, right? Now, when we look at this equation, this is what we call a linear equation. In one variable. Now, I did mention that when we first started these, in one variable. That's kind of like not stressed a whole lot, but I'm stressing it right now. I'm making sure you understand. It's an equation where you have one variable involved. I want us to compare that to this new equation, all right? 2x plus 4y equals 8. So what I've done here is it almost looks like the same equation, but I've added this y in here, right? Instead of having just a 4, I now have 4y. So there's a major difference between these two equations. The first one is called a linear equation in one variable. The second one is called a linear equation in two variables. I've always thought that this word in is kind of odd. It should just be like linear equation with two variables or something like that, but we say in. Okay, that's the way we do it. So a linear equation in two variables. So this is way different than the previous one because there is not just one answer. There are multiple answers. For example, let me just have you consider this. If x is 2 and y is 1, so if I ask you to just take that equation, replace x with 2 and y with 1, then let's see if it would be true. So take the equation, I'm going to do it in a different color. I take this equation up here, I replace the x with 2, I replace the y with 1, and I ask myself, is it true? So that's a question, is that true? So we just do our order of operations. We do 2 times 2, that gives us 4, plus 4 times 1, that gives us 4, and 4 plus 4 is 8, right? So that is true. So one possible solution would be that pair of numbers. So we call that a solution pair or a pair, We actually call it an ordered pair, but I'll get to that in a minute. So that is one possible solution, just letting X be 2 and Y being 1. But it is not the only solution. I could try something else. How about this? How about if X is 4 and Y is 0? Will that work? Okay, let's see. We plug in 4 for X, we plug in 0 for Y, and we ask ourselves, is that 8? And hopefully you agree that this is going to be 8 plus 0, and that is 8, and it's true, right? So we have another solution, a pair of numbers that is a solution. Does this mean that all pairs of numbers work? No, we could try, let me try something else. Like, what about if X is 2 and Y is 2? If we try that, we get 2 times 2 plus 4 times 2, and the question is that 8? And in this case, it's 4 plus 8, and that is not 8. So that doesn't work. So this would not be a solution. So the question becomes, if there's more than one solution, how many are there, and can you list them all? Like, could you actually list out all the answers? And the short answer to that is, well, there are an infinite number of answers, and it's impossible to list them all out. You would die before you finished your list, okay? You could start right now listing all the pairs that work, and you would die before you finish that list because the list is infinite. So is there a way that we can represent these answers in a way that you can see all the answers at the same time? And the answer is yes, we can. And that's where the whole idea of a linear graph comes from. A linear graph is just a visual representation of all of these answers, the infinite set of answers. It's just a visual representation of it. So what we do, I'm going to stick with this example, okay? So I'm sticking with this right here. I'm going to try and visualize these solution pairs. Okay, so what I'll do is, I think I'll start a new page. I'm going to change my paper to graph paper instead. I'm going to insert a graph into this. And that's not going to work because that's white. Let's go with blue. Okay, so what I have here is our standard two-dimensional coordinate system. Okay, this is what is called our x-axis, and this is called our y-axis. I know most of you know this already. Okay, and we have our equation over here: 2x plus 4y was equal to 8. We said that the first answer that worked was, what was it? 2 and 1, right? X was 2 and Y was 1. So what I'm going to do is I'm going to write it this way: 2, 1. So the first number will always represent the X, and the second number will always represent the Y. And this is known as an ordered pair. That ordered pair represents one of my answers. So what I'm going to do is I'm going to go graph that on this axis, on the XY axis. So the 2 means I'm going to move to the right 2 on the X axis. And then the 1 for the Y means I'm going to move up 1 on the Y axis, and I'm going to place a dot there. That dot represents one of my infinite number of solutions. Now, I had another one, didn't I? What was my other one? 4, 0. The X was 4 and the Y was 0. So let me go put that on this coordinate system. So I go out, let's see, X has to be 4. 1, 2, 3, 4. Here's 4. And Y being 0 means I don't move anywhere up and down. I just stay on the X axis and I draw another dot. Okay. Let's see if we can't find another answer to get a better picture of what all these solutions look like. Can somebody tell me an answer? just by looking at the equation? Can somebody give me an X and a Y that would work here?
0, 2.
0, 2. 0, 2. So if I replace the X with 0, I get 2 times 0 plus 4 times, and replace the Y with 2. Is that equal to 8? Yes, that works. Good. So 0, 2 would work. So 0, 2, 0 for the X means don't move left and right. Just stay where you are at the beginning, at where they cross each other. And then from there, I move up 2. So up 2, I place a dot. Okay. Let's do one more. Can someone think of one more? I'm going to ask, can somebody give me an ordered pair where one of the numbers is negative?
-2, 3.
-2, 3. So let's check. 2 times -2 for the X plus 4 times 3 for the Y. Is that equal to 8? Well, that's -4 plus 12, and that is 8. Good. Yes. I don't know who said that, but good. Did you just kind of think through that?
Yeah, I just looked at the graph and kind of like the pattern.
Okay, got you. Yep. Okay, so -2, -2 is here, and then up 3, 1, 2, 3. And what you should start to see here is that even though we could sit here for the rest of our lives drawing dots, it appears that all the dots lie on a straight line. Doesn't it look that way? And doesn't it look like I could draw a line? Hold on, let me change this. Let's go with red. I'll go with pink. Okay. Doesn't it look like all of those points lie on a straight line? Right? So it turns out that if you draw a straight line through those points, then every point on that line, every single point, and there are an infinite number of points, every point on that line should be a solution. Like, for example, can somebody tell me what that point is? It looks like that point's on my line, right? Can somebody tell me what that is as an ordered pair? Like how far, like what's the X and what's the Y?
8, -2.
8, -2. It looks like that point should work. And we could check it, right? Let's just plug it into this. 2 times 8 plus 4 times -2. Is that equal to 8? Let's see, 16 plus, well, actually, that'll be minus because it's 4 times -2, so -8. Is that 8? 16 minus 8? Yeah, that's 8. So every single point, now that means you could even pick points that were like fractions and decimals. Like that point would be like, I don't know, like 5.5, and I don't know what the Y would be, but every point, there's a solid line. All infinitely many points now represent all the answers. So a line is simply a visual representation of the solutions to a linear equation in 2 variables. That's all it is. All right? That's where the whole idea behind calling it a linear equation, the whole idea behind that is the fact that the graph of the solutions is a line. That's where the name comes from. So our goal, okay, our goal is I give you linear equation, you give me the line. You draw it. Okay, that's the goal. I'm going to give you a linear equation, and you're going to draw me the line. Now, before we do this, can somebody tell me what the minimum amount of information you need in order to draw a line. If I ask you to draw a line, what do you have to draw a line?
The X and the Y.
Okay, well, I'm not quite sure what you mean by that.
You need this.
Like, I don't know.
Okay, I'll let you think about it. Someone else?
The slope and the Y-intercept.
Okay, so now you're starting to talk about things that you've learned already, right? Slope and Y-intercept, all that, yes. But I'm just saying right now, if I ask you to take out a sheet of paper and there's a specific line that I need you to draw, what information do you need? Could I give you just 1 point?
You need both.
You need 2 points, right?
Yeah.
That's what you need to draw a line. But that's all you need. If I give you 2 points, right? If I just say, hey, here's a point on the line and here's another point on the line, that's all you need to ever draw a line. There's only one line that goes through those two, right? There's only one. So all we're going to do to draw a line, I give you an equation. All you have to do is come up with 2 solutions, 2 ordered pairs that work. If you can come up with 2 ordered pairs that work, you're in business, right? You're in business. Now, the way that we do that, there are 2 different ways. So let me write this down. So to do this, for you to give me a line, you're going to need 2 points, right? Once you have those 2 points, you can draw me a line. The way you do it, though, the way you get the 2 points, there's 2 methods to do it, okay? There's 2 different ways that you can come up with the 2 points. The first one is called the intercept method. And the second way is called the slope intercept method. And I'm not sure who said it. It's weird. When y'all talk, I can see who it is. It draws a little box around you. But then y'all are constantly changing positions on my screen. So someone said something about a slope and a Y-intercept. Was that Anastasia? I don't know who said that. But whoever did, that was referring to that method right there, which I will talk about. Today, we only have 20 minutes left. I'd like for us today, our goal to be to talk just about the intercept method. Let's make sure we understand that. And then next class, we'll talk about the slope intercept method, all right? And for both of these methods on a test, I don't care which way you use. Like, I don't care. You just need to draw me the line. Each one of these has strengths and weaknesses, all right? It just depends on the equation and the way it's presented to you, all right? So let's first talk about the intercept method, all right? So to talk about the intercept method, I want you to understand something about lines. Hey, now I have a pink, okay. So if I were to just draw a line right now, okay, I'm just gonna draw a line. There we go. When I draw a line, the line crosses through both the X and Y axes. Right? Do y'all see that? This point is called the X-intercept. And this point is called the Y-intercept. Can somebody tell me something about the ordered pair at each of those? There's something you definitely know already.
There's a 0.
Okay, so on the X-intercept, okay, so on the X-intercept, this one, what can you tell me? Something is 0, I didn't hear you.
One of the numbers is always going to be a 0.
Okay, so for this one, for the X-intercept, which one would be 0? Think about X and Y, right? X is left and right, the Y is up and down. So if we're talking about the X-intercept, what part of it has to be 0?
The Y.
The Y has to be 0. So if you're on the X-axis, does everyone agree that the Y would have to be 0? Right, because you're not moving up and down. So the only question left to us is to figure out what the X part would be. We'd have to go figure that out. Now on the Y-intercept, you don't move left or right, right? You only go up or down. So which part of that one would be 0?
X.
The X, right? And then we'd have to figure out the Y. So that's what this method is all about. We are going to take an equation and we're going to say, hey, look, let's just find the X-intercept and Y-intercept. Let's just find these 2 points. Once we find these 2 points, We'll just draw our line. So to find the X-intercept, okay, to find the X-intercept, that's this one, what we're going to do is we're going to use the fact that the Y has to be 0, right, at the X-intercept. So to find the X-intercept, we are going to set Y equal to 0 and solve the equation for X. Okay, that's how we find the X-intercept. To find the Y-intercept, we're going to do the opposite. We set the X equal to 0 and solve the equation for Y. And that's because when we're talking about the Y-intercept, the X is 0 there, always. Now, I told you there's pros and cons to each of these, right? Can anybody think of a time where this might not work? Can you think of a time that you could possibly ever have a line that did not have an X-intercept or did not have a Y-intercept? Look at the graph. Would it be possible for me to draw a line where I didn't have an X-intercept or that I didn't have a Y-intercept?
A horizontal or vertical line.
Yeah, what if I draw a horizontal line? What if I draw a horizontal line? What if a line goes like this, straight across? I'm not going to have an X-intercept, right? Or if I draw a vertical line, I'm not going to have a Y-intercept. So there's two like very special cases where this method won't work. But we're not going to freak out about that. We're not going to get worried about it. We're just going to, let's do an example. This is the main point right now. This is what we do. In order to use the method of intercepts, we're going to use that method right there, okay? So let's start with a fresh page, and it's 10:30. Let's see what we can do here. So I'd like for us to sketch 2x plus 4y equals 8. Okay, so that's the problem we started with today, right? That's the problem we started with. Let's act like we didn't do it, and let's see if we can't come up with the graph of it. We already know what the graph looks like, but let's just do it. So we're going to use the intercept method. So the first thing I'm going to do is I'm going to find the X-intercept. To do that, I'm going to set y equal to 0. Okay, so let's do that. I'm going to rewrite the equation. 2x plus 4 times 0 equals y. And notice by replacing the y with 0, this part goes away, and all you're left with is 2x equals 8. Now that is a linear equation with one variable. See, we've killed off the y. So you should be able to solve that using the methods that we've already learned. So try and isolate the x. So all you would have to do here is divide both sides by 2. So divide by 2, you get x equals 4. So here's what I know. This line hits the x-axis at 4. Okay, so I've got one of the 2 points now. Now I go to the second part. I want to find the y-intercept. To do that, I set the x to 0. I rewrite the equation, replacing x with 0. This time, this first part goes away, and you're left with 4y equals 8. Again, you have a linear equation with one variable now. So we'll just isolate the y by itself. We will divide both sides by 4. And you get y is 2. So I know that this line hits the y-axis at 2. And at this point, I'm ready to draw. Okay, so here I'm going to come and I'm going to mark out, let me see here. Here's 1, here's 2, here's 3, here's 1, 2, 3, 4, 5. So my first piece of information that I have an X-intercept at 4 means that I need to move out on the X-axis to 4 and draw a dot. And then I'm going to go on my Y-axis for my Y-intercept to the point 2, which is right there, and draw. And then I'm going to break out my little ruler. I don't have a ruler. So I'm going to draw a straight line through those 2 points to the best of my ability. And I'm going to cheat. I'm going to use the computer to do it. So when you're doing these, you don't have to be perfect, but you know, try and use as much of a straight edge as possible to make it look like a nice line. There it is. Okay. That line represents all the solutions. Any questions? All right, I'm gonna put another one up here. I'm gonna let you work on it. Did y'all like that when y'all worked on your own? Was that kind of kept you going a little bit? All right, here's a new one. Same instructions. I want you to sketch this. Use the intercept method. -3x plus 4y equals 24. Okay, it's 10:34. I'll put the poll up again. When you finish, click yes, okay? Let's see how far you can get on your own here. Looks like most of you are getting finished up here. Who wants to share with me what the X-intercept is? Taylor?
I got -8 for the X.
-8. That looks right. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So -8. You put a dot here. What'd you get for your Y-intercept, Taylor?
6.
6. So 1, 2, 3, 4, 5, 6. And we draw a straight line through there. Not bad. I did that by hand, so it's not great, but it is what it is. Okay, that is correct. So hopefully everyone got that. If you didn't, then I can answer questions. I'll end class here in just a moment. Let's take a look at the packet and talk about the homework. So let me get to the homework. So here's the homework. For these problems, what I want you to do is just draw the lines, okay? Like the instructions here says, find 3 different solutions for the following equations. That's just asking you to like go figure them out in your head or just work them out. Instead, I just want you to graph this line. Okay, so just graph that, sketch that. And then for these, same thing, just try and sketch them. Now, I know you're gonna run into problems with this because fractions, we have fractions. And here they're asking you to graph. I don't see any fractions. So there's a few things we haven't talked about. I expect you to run into some issues with, but try and get through the first 10. So this starts on page 55. Try and get through the first 10, see how it goes. If the ones with fractions throws you off, don't worry too much about it. I'll do an example next class with fractions. And then there's also these, number 6 is going to be tricky because that's going to be confusing to you, how to do 6. And then also number 10 is going to be a little tricky. So if you have any trouble with the fraction one or number 6 and 10, just skip it. We'll come back and I'll make it make sense next class. Okay, let's call it a day. I'll hang out here for a few minutes if anyone has questions on this sketch, if they didn't get it right or if they have something else they want to talk about. Okay, y'all have a good day.
All right, thank you, sir.
Bye, sir. Have a good day.
You too. Any questions?
The other method you had mentioned before, what was it called?
The slope-intercept method?
Right. So that's the one that we like set it equal to the y equals mx plus b.
Yes, and we'll do that next class.
Okay.
Yeah. So you're probably more familiar with that one. I mean,
Yes, I am.
That's a great method if it's already solved for y, but if you actually have to go solve for y, it's kind of a pain in the butt. Like here on this problem that we just did, right? Like finding the x and y intercept is just really fast, right? We didn't have to solve for y. We just plug in 0 for y, figure out what x is, plug in 0 for x, figure out what y is, boom, we're done. But if it's already solved for y, then it's easier to do it the other method, but we'll do that next class.
Okay. I was just making sure.
Yeah.
Okay, thank you.
Okay, thanks, Emily. Have a good one.